Okay, so I think we've got a few more people. There's still people joining. And I guess we'll start to respect everyone's time. And then as other people join, they can catch up with the recording or the slides. So many of you are here because you've used OpenFaas or have an interest in it, and you've maybe been following the project and community going all the way back to 2016. Some of you are a bit newer to the community, but everybody's welcome. And today we're going to go through the 2019 update. So we'll start off looking at across the years, going all the way back to 2016. Why did the project start? What are some of the sort of statistics that have grown? What are the signs of developer adoption? And how is it being used in the enterprise by end users? We'll then look at a bit at a demo. We're going to see a few different things, including combination of technologies and some of the landscape. And then we'll look at the roadmap for 2019 and some of the items that the community is working on already. Now, you'll also have a chance to get involved and find out how to get in touch with us at KubeCon if you're going next week. And please feel free to tweet any photos you find interesting, any screenshots of the deck using what we've got below. I'll also ask everybody to put themselves on mute. And if there's any background noise during the talk, I'll just remind you again. So the landscape as we've seen it, probably, I think this came out in 2017, maybe late. Maybe 2019. Let me see if we can mute people. Patricia, can you mute yourself, please? Please could everybody put themselves on mute? Thank you. Sorry about that. So the landscape that we had, this started probably in 2017 and it rapidly grew. This is a dedicated landscape just for serverless projects. We've got all sorts of things in here like tooling and framework security. And then additional frameworks that can be used with these platforms. On the left-hand side are hosted platforms. These are completely proprietary platforms. They're not open source. They're hosted by a third party. On the right-hand side, we've got installable platforms. Some of them are closed source, but all of them can be installed on your own infrastructure or on the cloud. So that's the landscape as it started to emerge. And we see that there's this split between the open source or installable software and the hosted platforms. Now, if you're a customer of a Serverless 1.0 platform, you probably were on the left-hand side of that diagram. If you're an Amazon customer, you wanted functions, you would use Lambda. If you were a Google customer, the only option you'd have is to use Google Cloud Functions if you wanted to leverage your existing billing and accounts and etc. Now, with each of those platforms, there's their own set of limitations that are baked into the platform that you really can't change. So there's a hard-coded limit for execution. It used to be 5 minutes for Amazon. They upped it to 15 more recently. But if you needed more than 5, before it was available, you're really stuck. Now, you're also limited to whatever regions they decide to make available to you, and whatever integrations and tooling the ecosystem provides. Amazon Lambda has had more tooling produced for it than Google Cloud Functions, for instance. So you're somewhat at a disadvantage depending on which you pick. Now, when it comes to packaging up your code, we're really looking at zip files here, which is where if you're using native modules, maybe you've got a machine learning module or something with ImageMagick, you have to download the specific Amazon Linux image from the cloud platform, build your local DLLs, and then upload them in the zip file and hope that Amazon doesn't patch that Linux version in the meantime, because it will completely break your function. So the way of working is effective, but only if you're going to be within that one tier and you don't need more control. Now, when it comes to the workload, there's also issues around portability. So the function that you write for Lambda is going to have a different signature from Google Cloud. And in the serverless working group, this is one of the things that came up. We started to look at, could we consolidate the function signature? And this was one of the hardest areas to get people to agree on. Now, when you come to the enterprise, next week in KubeCon, I'll be speaking with British Telecom and Yoast. You're really kind of stuck. There is no serverless platform that is exactly the same as this that will run on your own infrastructure, or at least there wasn't. There's no packaging, and it turns out that a lot of companies still have microservices and should do and need them. And there's nothing for them. If you're a Lambda customer, how are you going to run your microservice? It's just not part of the current landscape. Now, there's some pain points with this as well. The new stack recently interviewed 250 people. A lot of them had issues with portability, but I think for some people, if you know that you're in a single cloud and you remain there for the rest of your time, perhaps control is more important to you, or some of the other things that came up here. Debugging and tracing can be hard when the platform you're developing for is run by a third party and you've got no visibility into it. Lack of skills is a surprising one here, because serverless is supposed to be something that's really easy. How can there be a lack of skills? And then lack of tooling, again, which goes back to the fact that the most popular platform is the one that's going to end up getting all of the tooling for it, and the others will suffer. So I want to introduce you to Serverless 2.0, and this is part of the journey and the reason that OpenFaas came to exist. Serverless 2.0 is where you can run your code anywhere you want on any cloud. Now that could be a microservice or a function or some legacy binary that you've been able to wrap up and deploy as a serverless function. ThoughtWorks said that the idea of lock-in is actually something that's not binary, it's not 0 or 1, there's shades of gray. And within that, they said by using Docker images, it will mean that you're much more portable and you de-risk your deployments. Now with this, Serverless 2.0, you still get that auto-scaling that you were enjoying in the cloud. And if you're running on the cloud, you can even bootstrap additional nodes using autoscalers as needed. So what we need is a contract, because we're not going to be able to do this if we carry on doing things we always were with zip files. And that contract I want to propose is a Docker image exposing HTTP on port 8080, which is stateless and can be treated ephemerally. So it can be taken away, we can add new ones at any time, but also it's immutable. That means that it can never change once it's deployed. If you want a new version, you build a new version and have that deployed. Now this is quite a simple contract, really. When you think about it, if you have a microservice that exposes traffic on 8080 and you put it in a container, it's Serverless 2.0. I'm happy to say that this has been adopted by the OpenFaas project, and Knative from Google has followed suit. And that means that anything you build on OpenFaas will automatically work on Knative without any changes. Now, Kelsey Hightower recently said that multiple tools can coexist. And you may think that when a new project comes out from a very large vendor and gets a lot of hyper marketing around it, that everything else should step aside. And if you're not a big boy, you can't play in the playground. Well, this is from Kelsey, who's the chief evangelist at Google. And he's saying, pick the right tool for the right job. And so that's why I put together a Serverless 2.0 landscape. Now this shows 2 or 3 projects that are currently popular. And obviously there's additional stuff here that maybe isn't covered or isn't quite as clear cut. Up at the top, we need some way of building these images, that packaging problem. Well, that will be through some build templating system. We want to get our source code and produce a Docker image. OpenFaas can do that for you. BuildPacks, a CNCF project, can do that. And Azure Functions has released an open source component that can build a container image for you. Now, you're also going to need somewhere to run that, and you're going to need a serving runtime. If we look down the diagram, OpenFaas, that's been around since 2016, provides that, and many users are happy with it. Yet, last summer, Google announced the Knative project, and they're doing serverless in their own way for their customers. Whatever you build in the top layer can run in the layer below. Now, popular in the cloud is scale to zero, because cloud providers have a multi-tenant system and they need to squeeze as much value out of it as they can. But we can also get scale from zero, if you want it, on our own deployments. OpenFaas and Knative both support this, and Microsoft launched a project in December called Osiris, which also works with Kubernetes deployments to scale to zero and back. Underneath this, you either install onto Kubernetes or OpenShift. Both platforms are effectively the same kind of API, fully compatible. But there's a new option here, which is you can actually deploy to a hosted platform too, and then you get the best of both worlds. So you have the Docker image, the serving runtime, you can debug it locally exactly the same, but then you can host it on Google's new Cloud Run product, on OpenFaas Cloud from the community, or Azure Functions. So this is about big tent thinking. This is about collaboration and taking this rich ecosystem and building more innovation out of it. So OpenFaas really targets users that want something that's simple, easy to use, and lightweight. At rest, a DigitalOcean cluster with 3 nodes occupies around 400 megabytes of memory. When you deploy OpenFaas, another 800 megabytes are required. So quite a lot of headroom left. When I deployed Knative with the default install, because of some of the components they bundle and some of the end users they're targeting, it used up 14 gigabytes of RAM. And so I just want to show you that OpenFaas is developers first, and we're targeting something that's very simple and lightweight. Another project that has that same ethos is Linkerd too. Today, Matthias from South America did a little experiment for me. I asked him if he could get Linkerd a service mesh working with OpenFaas, and it took him 20 minutes. Now, when you look at a project like Knative, it comes bundled with Istio, and that's another service mesh. OpenFaas also works with that. But here you've got the option to pick whichever makes sense for you, and if you want something that's very lean and understandable, easy to use, you can combine the two. Here what we're seeing is end-to-end encryption, right from the TLS certificate on our ingress controller through to our function. You see a list of functions is being invoked right there. So my highlights of the last year were that we relaunched openfaas.com, and a guy called Alan Jarl did an amazing job of redesigning that for us. And Alan from Form 3 put in all of the hard work of reskinning the website. Really, really happy with it. The template store was launched, which means that you can get new templates and provide your own. There's 3 different Java templates, including Quarkus and Vertex, very enterprise ready. And we've even got ones for things like Rust. The OpenFaas community has built a cluster where you can actually just go and test stuff out in the cloud and get endpoints for free without worrying about it. You can bootstrap that yourself in 100 seconds, and you can also use you can also use it to deploy your own code. There's a guy, Rajat, who built a bot called Good First Issue. And what it does is you add it to your GitHub repo, and when you have an issue tag like that, it will tweet about it. And I noticed that the Knative project has actually added it onto one of their repos, and we have it on some of ours. And even the Helm project is using this now. It's a great example of how OpenFaas has enabled that innovation. Over those 3 years, we've now got 1.4 thousand Slack members, and that is going up every day. 400 of those joined since January alone. We've got 17,000 GitHub stars, which is around a third of that of the Kubernetes project, for some context. And then something I'm really proud of is we've got over 200 people that have sat down, decided to contribute, had a PR merged, and that's been released into the public project. There's 32 million GitHub pulls, and this is going up quite rapidly too. And it's an idea of some of the traction that we're seeing. Something that I really love about the community is this grassroots origins. Our first meetup group was actually formed in Bangalore and currently has 500 members, and they celebrated that last week. In our community file, We've got 120 events that people have run about OpenFaas, or talks that they've given, and 160 blogs. Now, if you project that forward for 2019, we're looking to get almost 300 blogs written about this community project that was basically staffed by volunteers. And I think it's absolutely amazing to see this traction. Now, for us, community is about people. And when you land on the OpenFaas homepage, a random selection of all of the contributors is shown like this. And that just shows how important they are to the project. This isn't something that's hidden away or rolled out for a keynote. This is front and center to the whole project. In fact, our most popular webinar was how to contribute. And around 60 people joined to find out how they could be a part of something bigger. Within the community, there's a smaller group called the core contributors and then the members. And altogether, there's about 13 committed people that are there day and night, helping people out, committing code, traveling around the world. And again, these are people that are very loyal, very skilled, and just love what they're doing. Stefan in particular is currently in the limelight for a project he created called Flagger. And this works with Istio, and it allows continuous deployment to be tested out instead of having guesswork and manual code. I'm very excited to see what he's doing with that. Now, developer growth is skyrocketing. These are some of the stars just on one of the repos. I expect this to continue to grow. You can see at the beginning when the project was first launched, and then when I spoke about it at DockerCon, how this just absolutely shot up. And this is because you guys are using it and you're giving us feedback, and we're taking it on board and improving the project. Within the end user community, there's currently 40 companies that have gone to their CIO or their manager and had written permission to have their logo listed here, and many more that haven't been through that process yet or are on the way. One of the most recent is the Press Association, BT and Whitel. I'm going to tell you just a little bit about what they told me. So Chris Thorpe from the Press Association got in touch only last week, and he told me that OpenFaas has become a keystone of their deployment pipeline. Now, he's completely remodeled their development pipeline so that they can move away from older infrastructure automation, things that were very slow and heavyweight, and now they have something that's much more lean. And for them, OpenFaas is bringing a greater automation, resiliency to their deployment process, and much quicker deployments overall. For him, his top features are the resiliency that you're getting from Kubernetes, that portability because they have more than just one set of computers to deploy to, one set of clouds, and the built-in metrics and auto-scaling. For Whitel, a carrier that allows you to do SMS messaging and voice, for them, they just put together a whole bunch of functions in TypeScript and they run them on Google Cloud. Now, one of the problems that they had is some of their APIs would run for a long time, and that was giving a poor user experience. So Daniel told me how they were able to actually make that shorter by running them through the asynchronous behavior OpenFaas has. Alejandro, could you mute, please? Now, they're also able to now process more transactions quicker, they get less errors, and they can scale the traffic. Not because OpenFaas has auto-scaling alone, but because they've been able to carve off busy areas of the code and make those functions. That's something that I saw here for the first time. Now, they also like the fact that you can use a Docker file, and that is something that you can't do with many of the other providers. So they can move between stacks very easily. Joost Noppen from BT got in touch with me, and he told me last year we've been using OpenFaas for 7 months. We've been kicking the tires, building stuff with it. We really like it, want to get in touch. And now they've been able to build a complete pipeline to automate and package AI algorithms. We're going to speak about this at KubeCon next week. And one of the things I liked was that the old way used to take them 3 years, and the new way to deliver value takes 3 months. Again, for them, having automatic endpoints, metrics, and scaling out the box is saving them time. They also are really fond of the fact that we have these industry standards, this idea that the Docker file can be used and these images are portable. They can run that either on premises or in one of the clouds that they have. And that just sums up a little bit about how end users are making use of the project now. If we look at the architecture, we've agreed on this Docker image format, the Serverless 2.0, port 8080. How do we get it into the cluster? Well, to use a command line, a UI or REST, that's all exposed at the gateway on the top right, top left. Now, if you were to deploy a function, the gateway will then call something called the provider. And the provider, if it's for Kubernetes, will create a pod. If it's for another container orchestrator, like Titus from Netflix, then it will go off and create whatever abstraction they're using. On the right-hand side, then you'll have your functions, and that's it. You can deploy them, invoke them, and it goes through that path. Where we add additional value is by collecting rate, error, and duration metrics using Prometheus. And because all the traffic goes through the highly available gateway, we can then use that traffic and that data to scale ourselves up or down using Alert Manager. Now, there's an API, so you can actually build your own auto-scaling if you want it. The other item on this screen is the queued invocations using NAT streaming. Here, you can run those jobs that Whitetail has, give your customers a faster experience, and do the heavy lifting on the back-end tier. We also added support for ARM 32-bit Raspberry Pis, but ARM 64-bit. And I was really excited to see Docker give official support and build a partnership with ARM. Following suit there, we saw Red Hat do the same. And so OpenFaas is ready and primed to be deployed on ARM 64. And if any of you are interested in that, please come and follow up with us. So this isn't just about HTTP. Sometimes, you have other kind of event sources, and OpenFaas is aware of that. In the project, we added connectors for SQS, SNS, Kafka, just to name a few. And the way they work is you use a small Golang SDK, and you will connect to your broker or your event source using that. You would then decorate your functions with a topic, so cart checkout, for instance, and deploy your function. Then the SDK that you vendored, that you built into your project, will look up for each message whether there are any functions to invoke, and it's just quite a seamless integration. Now, one of the other things that's been built out even more is the ecosystem of OpenFaas. So we have a function store that allows you to share functions very quickly. One of those that some of you may have seen was a colorization, and I posted a blog post on this today, and turn a black and white photo to color very quickly. Once you have OpenFaas, you're only one click away from deploying that. We've got the templating system that allows people to submit that Quarkus, Vertex, and Java template and then share it with the entire community, and also the ability to just run microservices. So I'm going to give you a quick demo now. And what we'll do is, first of all, I want to show you over on my Intel NUC. I have a single node cluster with Kubernetes. And if I use my CLI, I can list what functions are available. Currently, I have one function from the store. I'm going to deploy another function. I'm actually going to deploy an echo function. On the right-hand side of the screen, we can see the pod has been created in the namespace. It's now up and running and ready to receive traffic. So if we curl the pod, we get a result back. We've got the duration that it took, but we also have those rich metrics in Prometheus that we can access later. What I'm now going to do, I'm going to scale this down to 0 replicas. And for some of you, this is going to be irrelevant. Basically, you may have a function that is so important to your business that you just want to make sure there's always some availability of that. But for other functions, maybe for your Slack bot or things that run on an ad hoc schedule or are triggered by events, you may want to actually just go ahead and scale them down when they're not being used. Now, when I invoke this function, we look over on the right-hand side of the screen where it says terminating. We first see pending, container creating, running, and then within, in this instance, 3 seconds, we've got our endpoint up and running. And we can repeat that experiment. Depending on the size of your image, this will go down to as little as under a second. Here we had 2.2 to cold start that function from scratch. Now this is OpenFaas running on OpenFaas, running on Kubernetes. We've got a Golang function, and we have a stack YAML file, an OpenFaas YAML file. It says what the images we're publishing to. It tells us what kind of template to use, where the code exists. Now, one of the projects I mentioned earlier was Knative. So I want to show you that I have Knative deployed on a Packet.NET machine here. And one of the things I want to do is deploy something from the OpenFaas function store directly to Knative. First of all, we'll have a look at what we've got. We've got this one called Figlet, and Figlet will just give us some text in an ASCII format. So what I want to do is use my saved command to generate a CRD or a custom resource for Knative. Now, as you see, this is slightly different from the one that we had in OpenFaas, but it's basically got similar information. It's got the container image, it's got the name, and any additional secrets or environment we need. From here, I can pipe that into a file, Figlet YAML, and then I can simply use kubectl to create that. And if we get our pods, we'll now see that Istio is starting, Envoy is connecting, and Figlet is up and running. From here, I can now use this quite complicated curl command to go away and look up the address in Knative and invoke the function. And there we go, we've got the result back. Now, if we were to remove this container, or if we try this later in the presentation, it currently takes between 7 and 9 seconds to cold start the same function in Knative. So it's several times slower, but I'm sure that the team at Google will improve that over time. And one of the other things that we can do is also generate a CRD for any other function that we happen to create. So if we were to have a look in the store at templates, we can see that there's that Rust template I mentioned. We can pull that template in and then create a new function, call it Rusty. And exactly the same way as we did before, we can generate a CRD for this. And all we have to do is just pass in the YAML file. And there we'd be able to deploy that brand new OpenFaas function. Go back to presentation now. What we saw was OpenFaas functions deployed to both backends. If you deploy to Knative, you have none of the ecosystem. You don't have the auto-scaling or any of the other parts that we've added. You have to get that from their project and use their user experience. However, if this is something that you're doing, OpenFaas can add value for you through the ecosystem. So one of the other projects that has really taken off this year is OpenFaas Cloud. The idea here is that we've got some code on our laptop as a developer, and we just want a URL. We don't really want to know anything else that's going on in between. So OpenFaas Cloud came about to remove friction for developers, to give you a managed experience. We can just git push, and that's it. It's multi-user, which means that you can actually share this with your team or your friends, and you'll get a personal dashboard that you have to log in with OAuth to. So if you've got multi-factor enabled, or your GitLab is linked to OLAP, then you'll be logging in with Active Directory. Everything that we can automate is automated, and there's network policy enforcement, quotas, and limits on what you can do within that environment to make it more secure. The basic flow, this is a high-level conceptual flow, is that you'll do a git push, and your Git repo in your source control will then submit a webhook to a receiver. Now, this happens to be some code that we've written. That receiver will then find out what you committed, check that out and pull it in, build an image, and then push that image into a registry. Once it's in a registry, it will then just deploy it for you using the REST API. And it's exactly like what we just did a few minutes ago. You then have your functions attached, and they all have HTTPS URLs, and you can access them really easily. Now, unlike some other projects, this actually has one centralized webhook, which means it's very easy to set up. This is an example of the GitHub integration. And we also have GitLab. I committed some code. I've got my 3 functions have turned up. And they all have a tick because a unit test passed. And if any of them failed, I can click on it and see the logs. And they all appear on my own dashboard, just like this. And you can even get private repositories built in. When you dig in a bit deeper, you'll see a whole bunch of additional metrics, the invocations. And one of the things we want to add is the 99 percentile latency and some logging, right? But at the moment, you git push, you get this experience, and then you're able to invoke your function. Right? There's no Kubernetes, no pods, no complicated YAML files. But now I'll go on to a second demo, and what I've put together is a whole single page app. Now, this is because Serverless 2.0 is about functions and microservices, so I wanted to show you them working together. As people comment on a GitHub issue or open issues in the repo, we'll collect the statistics and show them on this leaderboard, and you're going to get a chance to participate. Matthias is about to drop a link for you into the chat. When you get that link, you'll comment on it, and then I'll show you that updating, and we'll have a look at how it worked technically as well. So if you're on here, go into the chat, and you'll see a message with the GitHub repo. So when you land on the repo, it's going to say, click here. And there's also a link for the leaderboard that I'll open in another window. Let's see, we've got 100 people on here. So there's 13 people that have done it so far. And my current count, as you can see, is 4. Now, give me 1 second because there's something I didn't tell you. I actually want to show you how this works. So if you hold on a second, we don't have a webhook yet. So the data isn't connected. What should we do? Well, let's go to my dashboard and see the function that receives the webhooks. This is called GitHub sub. Let's copy the URL and enter it here. Now there's a very secure secret that I'm also going to save, and then I just want it to send me only issues and comments. We'll add that. Okay. So if you commented, please do it again. And now we'll actually see it. I think there was Troy. Okay, so people are turning up on here now. And within GitHub, we can see these messages. Each of them is displayed, and we've got the username. If we dig into this, we'll find the person. So we've got David. Thanks, David. And then there's a response that came back from that function. And we've got everybody turning up here. Now, the other thing is, because this dashboard is recording the invocations, well, over the last hour, we only had 0, actually. Let's refresh it now. We see we've actually had 13 people that have just participated and left a comment. Yeah, it's a good way to see who's paying attention. Thanks, Jeremy, in the chat. So when we go over to the main dashboard, we can also see that the leaderboard page, the traffic on that has gone up to 270. And if we want, we could now apply some load to that using a tool like hey, for performance testing, we'll say we want 10 requests per second over 5 minutes. What we'll gradually see is that 1 hour window of invocations on the dashboard is going to go up and up and up until we start to hit the limits that we've set for the scaling parameters. And then the replica count will increase. And we may come back to that in a minute. Okay, so we're at 500, 370. And this is updating every few seconds. So now our replicas are 3 out of 4. We're almost at the top end of that. And this is something that you can configure in the environment. And when we cancel the load test, we see we've got 100%, all very fast. And that will now scale back to 1 replica. So thanks for participating in that demo. This is how it worked. On the left-hand side, as a user, I was looking at the dashboard, which was the Vue.js microservice. That was actually connecting to a Go function that was doing a select from a stored procedure in Postgres in a remote cluster. At the bottom, as a contributor, you were commenting and opening issues, and then GitHub was sending that webhook event that I added during the demo for you, and then that was doing the inserts. And so this is how we're able to compile 3 different, completely different systems, OpenFaas, GitHub, and DigitalOcean's SQL, all together to make a complete app in a very short period of time. Now, if you wanted to try this, all you'd have to do is fork the repository and then install your own OpenFaas app on there, or the community app, and then update the secrets. It'd be really that simple to get your own. Now, some of the other things that we've done is we've doubled down on security. At the top right here, there's a video where Joe Bader had a look at OpenFaas and kicked the tires with a very, very young adolescent OpenFaas. And he gave out the public URL to the internet, and there was no authentication, and somebody deployed a Bitcoin miner. It used up all of his AWS CPU credits and crashed his cluster. So definitely an example of why we need secure by default. So what did we do? Well, we added into the platform a basic auth password that is always on. You physically have to turn it off if you want to. You'll get that when you bootstrap. We also made all of the containers that we deploy non-root. Not only the containers we deploy, but the ones you deploy, you can also opt to be non-root. So that means that your code can't be replaced by malicious code, and that your system layers can't be overwritten with malicious binaries. Very important. Now, OpenFaas Cloud has further security. We don't want you to put plain text secrets into your GitHub repo, so we seal them using Bitnami sealed secrets, and that encrypts them. Nobody can read them. And then there's that OAuth 2 that will federate into your own identity system. So it's been a great year for security. In terms of performance, well, we've added scale to 0 as well as scale from 0. And one of the VMware teams that was using OpenFaas had a very expensive demo environment. And they asked me at the time, is there a way we can spin some of this down to make it cheaper? And so this was one of the core reasons it was added. We've also moved to using HTTP probes. There's a bit of a technical detail here, but they turn out to be a lot more efficient over time. We have new templates. Some of you are familiar with this standard in, standard out Unix pipes that OpenFaas had in the beginning. We also have a HTTP mode now that's very fast and is suitable for serving web traffic. BT had been doing load testing, and they found a couple of points where we can make improvements around DNS. That was also done, and then I heard from several of the other end users that they're taking that patch and had a dramatic increase in performance. So this is something that's evolving over time, but we're taking very seriously. And then we also have the ability to support HPA v2 custom metrics out of Kubernetes through recent changes in the watchdog. This is how the scale to 0 and scale from 0 works. It's a bit like the diagram we had before, but I've taken some bits away. On the left, we invoke the function at the gateway. Now, if there's at least one pod available for that, if we follow that line, we'll hit the function and execute it. We'll get the result. However, if it is 0, it's going to scale to 1 and then ask the question again. And so we block the thread and block the connection until there's a pod available, or it times out, whichever comes sooner. Now, the other end of that is a scale to 0, which, again, some of you may not need, and some of you may want to build your own algorithm. We scrape metrics with Prometheus. The FAS idler component will then read that on a periodic basis and decide if the pod is idle, and if it is, scale it to 0, right? And then when you get the traffic, it's simply a case of that getting scaled up again. And so if it's a very simple model, it's easy to understand, but also because we have the REST API, you can extend it and even build your own. The top blog posts this year have been the serverless single page app that I showed you, how to build serverless Go, whether that's a function or a microservice. In the blog, you'll see that there was around a 25, 35 line Docker file to maintain for every microservice you might write. Well, if you use our Go template, there's only one and we maintain it and you don't have to see it. So you can concentrate on just writing your handler. When you deploy to Kubernetes without using OpenFaas, your YAML for a basic service with a few secrets might be as much as 300 lines. With OpenFaas, you're writing 4 to 8 lines of text. It's much simpler. You can also deploy OpenFaas Cloud with GitLab, and this is great if you're running on premises. So all of these are at openfaas.com. As we come towards the end of this session, the roadmap for OpenFaas, we're looking at how can we support multiple namespaces. So just like Linkerd and OpenFaas, the project, we're trying to keep things simple by not adding things when they're unnecessary or when they're not needed yet. And so all of this is being driven by user demand and the people making use of the project. Right now, you can install OpenFaas multiple times, or you could install it perhaps on different clusters. What we're looking at doing is having this ability to install OpenFaas once and then have each tenant in a different namespace. If that's interesting, you can get involved with it. We're looking at OAuth 2 for the REST API. Now, there's currently authentication there, but if we were to add OAuth 2, again, this might make it more appealing to the enterprise. Perhaps some of the people on the call here may want to comment about that. Lucas Rosler at Contiamo, a long-time contributor to the project, is currently working tirelessly on a logs feature. You can get your logs directly from kubectl very, very easily, but what we want to do is wrap that up inside our REST API and CLI so that you can get it in an even more consumable way. Now, a few people have been trying out systems that are a bit more complex, where they're using taints and tolerations and affinity rules in Kubernetes. That's something that I've not really seen in any serverless project as of yet. And we definitely have ways of supporting this now, but we want to make it easier and see if we can perhaps abstract the taints and tolerations and advanced scheduling ideas that Kubernetes has in a way that is going to be approachable to users. So to sum up, all of the benefits of serverless on Kubernetes, but it's lightweight, it's easy to use, and it's simple to operate. When something goes wrong, you're going to know where to look. It's been trusted in production by over 40 companies and many more that we're seeing every week. It supports OpenShift 3, 64-bit ARM, and we can even deploy to Knative. And the thing that I'm most proud about is that this is a real healthy organic community, and the entire thing has been built by volunteers. There's nobody right now that's paid full-time to work on this project. And we'd love to have you involved in this too and to contribute in any way that you like. Actually find that video that I mentioned, how to contribute, or even just ask on Slack. So thanks for being a great audience and for playing around with the demo. Really appreciate that. Got a few action items for you, ways to get involved. First is we'll be at KubeCon next week, and there'll be a whole bunch of us there. There's a blog post that you can read. You can find out when our sessions are and put them in your calendar. If you're there on Monday, you should definitely come to the Serverless Summit. and hear a bit more about these various serverless projects. And then the most practical step you could take today is just to grab a screenshot of this. Maybe someone can put this into the Slack or into the chat. Join us on Slack. And that concludes the presentation. So if we've got any questions, I'd be happy to take a few. You can unmute yourself.
Hey Alex, hi. Can you hear me?
Yeah, hello.
Yeah. Hey, I had a question regarding the Kubernetes configs. Is there a way to edit the liveness and the readiness, the health checks that goes on with OpenFaas deployment?
Yes, so I can answer that. The question is there a way to edit the liveness checks and readiness checks? There definitely is. So if I go back to my Kubernetes cluster and I look at the deployment for the gateway, we'll see that every function that's created has certain parameters here that represent what kind of probes we're using, how long we're giving it until we're going to check the readiness probe, how long that runs, and same for the liveness. So if you have a system where you're deploying code and you're not using scale to 0, you could put this as something very long, like 30 seconds, I think is recommended. And then that probe will run every 30 seconds. If you set it to something like 0 or 1, it's going to run much more frequently. But as we saw in our scale to 0 example, you do actually want that so that you could potentially scale up very fast. Does that answer the question?
Yeah. I guess this must be it.
This is configurable in the Helm chart if you want to edit it.
Okay. And it's the same thing that checks the temp, the log file. There's a cat on the log, TMP log file, right? That checks every.
Yeah. So there's an option to have a HTTP health check through here or an exec. One of the things that we've added recently is the ability to use HTTP health checks for the functions, and that means that they can operate much, much faster. And if you're using a microservice that doesn't have the watchdog, you can implement your own. And if you do want your own one inside your function, that's something we can look at as well.
Yeah, I was asking because it was too frequent for me, and while scaling it up, I have too many functions on one node, and then this gets, this is a problem when scaling up. Yeah,
so you can definitely tune this. And again, the Slack community is the best place to ask these questions, and also check out the docs. That's something that we did work a lot on to put together, and there's lots of information here, including reference about how to use the YAML and some of the events that are available. Has anybody else got a question?
Yeah, I've got a question, Alex.
Hi, Miles.
Miles. I noticed on the roadmap there's a stretch goal for integrating with an on-premises Bitbucket installation. And I just wondered if you'd give a quick overview on what might be involved in that. We've got Bitbucket and Bamboo locally that we're looking at possibly integrating with, and it could be that our company could contribute to that.
Yeah, so the first two integrations were with github.com, and that's what the community cluster runs on. There's a GitLab integration. The one that I was thinking of doing next is potentially Azure DevOps pipelines. But yeah, in the same way, what we need, if I go back to the presentation, is we need an event when you have push code. And then there's an additional integration for the authorization, which I assume would be available too. So I think it's something that could be done. Again, it would be driven by demand or some other kind of prioritization.
Sure.
Now you can use Bitbucket with OpenFaas. What I'm looking at here is OpenFaas Cloud, which is this complete integration experience.
Right, yeah, that's what I was referring to as well.
Yeah, okay. Great. Well, I mean, feel free to follow up after the call.
Yep.
I'll put it in the chat. My email is alex@openfaas.com.
Okay. Thanks so much.
Miles. Okay. We've got a little bit of time for a couple more questions.
Along those lines, does it support GitHub Enterprise?
I don't have access to GitHub Enterprise, but I have a couple of people that have told me that the same hooks exist as in github.com. And so I believe it would be possible to do that.
Yeah, generally it's depending on what version. Like if you're on a very old version, it may not, of course. But yeah, generally the hooks are the same.
So I would imagine definitely be possible. If that's something you're interested in, again, please reach out to me on that, alex@openfaas.com.
Thank you.
Hey, Alex. Can you hear me?
Hi, Stefan.
Hi. So I think if we write some docs around how OpenFaas Cloud authentication works with GitHub, let's say, and make those public, I think people could easily integrate with whatever other SaaS on-prem is there. We cannot cover all the Git hosting solutions. They are like in their own world, right? Like 10, 12 with all the open source stuff. So yeah. I think docs will help everyone, get involved, and it's a great space to contribute.
So we have a question from Christopher Adigan. Can we scale on metrics like CPU? So basically, the auto-scaling that's built into OpenFaas right now is one that is customizable. You can write your own alerts for this. But it currently looks at the rate of execution, and that's what it uses to do proportional scaling. We made some improvements to it through Simon Pesler from LivePerson, who's been using it at his company. But HPA v2 is also available from Kubernetes, and that would allow you to use your CPU and memory. Now, because we've put custom metrics in our watchdog, if you're making use of one of the watchdogs, you can actually use a combination of all three. So yeah, that's definitely something that can be done.
Yeah, so now we have capabilities of creating a single horizontal pod autoscaler definition that includes metrics from OpenFaas and metrics from your infrastructure, CPU, memory, and other things. I don't know, open sockets or memo. I don't know. There are so many things that you can scale based on custom metrics.
Yeah. I see we've got Troy. Are you still there, Troy, from Suze? Have you got any questions? Nothing from Troy. Anybody else want to ask a question? Or?
I'd taken my headset off.
It's okay.
I was actually just looking at HPA v2 stuff. I did have a question about the feasibility and usefulness of connecting OpenFaas to Cloud Foundry by way of the Open Service Broker API, where services available through, functions available from OpenFaas could be exposed to applications running in Cloud Foundry through the OSBAPI. Has that been considered at all?
So I think we've considered that the kind of something similar to that, which is maybe consuming services from the Open Service Broker catalog in OpenFaas. That's definitely something that would be interesting. But the other way around, I never really thought of that. So you would effectively request or access functions through the Open Service Broker, and OpenFaas would provide them.
That's the idea. So you would.
I really like that idea. I'd be interested in looking into it more.
Yeah, it's curious for me to think about building a bridge between your function catalog and the service broker, so that things that are running in Cloud Foundry could access these functions, and then the application would have the credentials and the connection string to access the function. So
yeah, that's true. And then perhaps also you would be able to access the whole function store and even have a custom function store that you can get into.
Yep.
I think OpenFaas works fine on PKS. So you could deploy OpenFaas with the Helm chart or even OpenFaas Cloud.
Yeah, for SUSE it's a little different. We would, and we have deployed it on SUSE's CAS platform. And I'm just trying to think of ways we can make them interoperate nicely.
Yeah, I think you could create some kind of first-class integration there. That would be really interesting, and maybe some people in your team could have a look at what it would mean to have OpenFaas call out to the Open Service Broker API, even to say, right, can you give me a SQL?
Exactly.
Like the single-page app I showed. That's something that I provision separately, or I provision through Terraform. It would be great if you could actually just request that too.
Yeah, and Andrew Gracie and I were talking in the background about maybe adding an optional or adding UI support for OpenFaas in Stratos, which is it's a Cloud Foundry UI primarily, but it's a sort of a multi-API consumer, so it can interface with Kubernetes, with Helm, and other things as well. So
okay.
that could be the link back to OpenFaas as well.
That sounds great. I mean, there's a bunch of people that are very, very busy right now contributing to the project. If this is something that sounds interesting to anybody, please just let us know in the contributors channel on Slack. Don't be shy. We'll try and find you something. We'll help you with it. I'm just thinking, Matthias, are you online? You're one of the newest contributors. What's your experience been like contributing to the project?
Hey, yeah, I'm here. Well,
you turn up a little bit?
Oh, yeah. Is that okay?
A bit louder. And then after we've heard from Matthias, we'll let everybody drop off.
Is that okay?
Yeah, great.
Yeah, so I've been contributing to OpenFaas for no more than 2 months. And honestly, it's been somewhat frictionless. It's with the help of Alex and all the community members, the core contributors, it's been really easy to get on board the project. And honestly, I've never seen any other project that is this welcoming and this easy to contribute to.
Wow, thank you. And thanks for turning around that that demo of Linkerd as well. And Matthias, that literally this afternoon. Really, really glad to have you here. So this is a place where everybody's welcome to contribute, to use the project, help us drive the roadmap. There's things we haven't thought of. We'd love to get your input. If you are an end user and you're using OpenFaas at work, please speak to your manager. See if you can get permission to get your logo listed on the homepage. And if you're actually making use of OpenFaas in your core business, think about if there's a way that you can sponsor the project on a regular basis or make some kind of one-off backing or donation as an individual. Really help with events like next week. Well, thanks everybody. I'm going to stop the recording now. We'll put this on YouTube in a couple of days, and we'll see you all on Slack.
Bye.
Thank you very much, Alex.
Bye. Thanks, Alex.
Bye-bye.
Thank you very much.
Bye. Thanks.